We want to make a 95% confidence interval for the percentage of subscribers who didn't expect to pay anything. So the sample percentage is 5%. How much do we go up and down from 5%? Sorry? So for conservative 95% confidence interval, we would ordinarily use Chebyshev's inequality, right? And the upper bound on the SD of the box, assuming that the SD of the box is a half because this is a percentage. Except, what's the problem here? How many people did she contact? How many people did she try to contact? How many people did she actually contact? She tried to reach 4,000, reached 400. That's an enormous amount of non-response, right? This is not a simple random sample, right? OK, the answer is E. OK? This is like, what I really, really hope you get out of this class is, when does the statistics not make sense at all, right? Because anybody can plug numbers into formulae. The question is, when is it right to use any formula, right? When is there no right answer? And if there is a right formula, what is it? I'd love for you to be able to figure out for yourself, to derive the formula for yourself in situations where there is a right formula, and to have a really clear idea of when all bets are off. And this is a situation where essentially all bets are off because due to non-response bias, that answer could have been anywhere from, what if the other, 3,600 people had answered? If they had all said that they didn't expect to pay any extra charges, then what would the sample percentage have been? Right? It would have been 3,640 divided by 4,000. Right? It would have been very, very high. Suppose that all of them had said that they did expect to pay other charges. Then the sample percentage would have been 20 divided by 4,000, which would have been microscopic, right? OK, so because of the non-response, you really have no idea what's going on here. And as the first question addressed, we don't have any reason to think that the non-responders are like the responders, nor that they're unlike the responders, but we also don't have reason to think that they're like the responders, right? OK, so it's not fair to assume that they're the same.